Going to begin talking about the top-down approach to winter weather forecasting. This is something that our two forecasters put together for us today. They're on the mid shift, so we went over it briefly this morning in order to make sure that I understood everything that was going on and what the messages that they wanted to relay were. So thank you, Michael and Jared, for doing this. We'll begin by talking about why using the top-down approach and why we use that in forecasting. And basically, the top-down approach to forecasting is, if you think about BuffKit and you look at your soundings, we're looking at the atmosphere from the top down to the surface, and what a hydrometeor, whether it be an ice crystal or a liquid, would encounter as it continues to move closer to the surface and eventually reaches the ground. So that's the top-down method to forecasting. That's what our grids use. That's how we do our winter forecasting. And so it basically looks at 3 steps. Is there any snow or ice in the upper reaches of the cloud? If there are, we take that into account. And then as that hydrometeor falls towards the surface of the Earth, is there any warm layer within that hydrometeor would encounter as it begins to fall that would alter it or make it melt or to all liquid, or maybe even make it melt a little bit if it's a snowflake, and it would have some riming that would occur during that melting process. And then lastly, what happens to that hydrometeor once it hits the surface or nears the surface? So this is a chart that we look at, and when you read our AFDs, you might see that negative 10 Celsius mark, or that threshold. That's what we look at when we're looking for the presence of the initiation of ice. So ice nucleation process begins when we have a relative humidities, above 70–75% within a cloud layer that's cold enough to support ice nucleation, and that does occur. 50 to 60% chance of that occurs when we reach that negative 10 degrees Celsius threshold. As we get colder, negative 12, negative 15, negative 20, we have the greater chance for the initiation and presence of ice within a cloud. So that's your the top of the cloud. That's what we're looking at when we're talking about the presence of ice and ice nucleation process. So step 2, is there a warm layer? So as this hydrometeor falls now towards the surface, will it melt, or will it encounter any warm air? We look for temperatures to be below 1 Celsius for us to continue to stay as all snow as the hydrometeor falls. If we have a shallow warm layer between 1 to 3 degrees Celsius, then we might see some partial melting on that snowflake. That riming takes place. So we'll have partial melting may occur, so you could start to have maybe some mixed precipitation. But by and large, if you have a solid snowflake, you can anticipate a snowflake to continue to descend towards the surface. And if we're greater than 3 degrees Celsius, then we're anticipating that hydrometeor to melt into all liquids. So think of your thick layers, your thick warm layers in the atmosphere. The step 3 of this top-down approach is what happens to the hydrometeors as they near the surface. So with that, we look at our wet bulb freezing height rule. So wet bulb temperature is something that you can overlay in BuffKit. So if you don't do that, as we move into more winter type activities this season, you might want to take a look at that wet bulb temperature, because what that does is that accounts for dry air within your column that would allow for that evaporative cooling to take place and actually cool your atmosphere more than what your temperature profile might be indicating. So for the wet bulb freezing height rule of thumb, what we look for as forecasters is if your freezing height, your wet bulb freezing height is 1,500 feet or greater, snow is generally rare. So if it's between 750 and 1,500 feet, snow is possible on the order of likely as it heads towards the 750 feet. And then if your wet bulb freezing height is closer to the ground, less than 750 feet, that's when we're expecting typical snow profile. For rain, it's a similar situation. So if rain is descending, what we would look for is if we have a warmer layer, then we can anticipate that rain to basically remain as rain as it descends to the surface. But if our temperature near the surface is freezing, then we can anticipate the presence of freezing rain or freezing drizzle. And similar story. So 750 to 1500 feet, we would anticipate rain or drizzle. If it's closer to 750 feet, so if we're colder as we get closer to the surface, then we can anticipate some sort of mixed precipitation in the form of sleet. So this is summarizing the top-down methodology. This is trained for Weather Service forecasters as well. This is something that I'm going through as a relatively new hire in the Weather Service. So the step 1, step 2, and step 3 approaches to the top-down methodology is something you might want to consider if you are doing your own forecasting this winter. And BuffKit is something that can really help you out with this, as you're just following that hydrometeor as it goes down through different layers at different temperatures closer to the surface. So this is what we're talking about when we're mentioning all of this, putting it all together into a sounding profile. This is what we would anticipate with snow. This is temperature below freezing through much of the column. And if you think about our dendritic growth zone, which creates those good dendrites, -10 to -20 C, if we have moisture in that layer and we're all below freezing, so as that hydrometeor descends to the surface, it will remain a snowflake. If you have a little bit of the presence of a warm layer, so we talked earlier, 1 degree Celsius to 3 degrees Celsius, we can anticipate that partial melting to occur. And you can see this in radar, and when we have that bright banding along the beam and we have like a lot of higher reflectivity, you can see that there's some melting layer occurring, so that hydrometeor is experiencing warmer temperature than as it descends to the surface, which would cause partial melting in the presence of potentially ice pellets or maybe rimed snow. And then for freezing rain, this is when we have a hydrometeor as a snowflake. It descends through a thicker layer of warm air, and then nears the surface, it becomes freezing or below, and below freezing at the surface would then indicate the freezing rain profile. So this is tied into reality. Like I said, when you look at BuffKit and when you're looking and analyzing our forecast sounding information, this is the type of approach that you can use during the winter season. So here's an example from last Sunday and Monday, our only winter weather event so far this season. This is out of Pittsburgh. This is from 0Z on November 2nd. And what this shows is temperature above freezing here close to the surface or at the surface, so we're 36 degrees Fahrenheit. But as you go up in the column through about 700 millibars, we have a very good saturated layer here, so our temperature and dew point pretty much meeting. And we also have moisture through our dendritic growth zone, which would be that -10 to -20 degrees Celsius range. So with that, we would anticipate the presence of snow. It probably wasn't sticking to the ground because we were warm. We were at 36 degrees Fahrenheit at the surface, but nonetheless, this is a good snow profile for Pittsburgh. Then 12Z, on November 2nd, you can see we started to lose our moisture in this dendritic growth zone, which is highlighted here in this blue shading along the temperature profile. So the Storm Prediction Center, which is where I believe they got this sounding from, it'll highlight that dendritic growth zone. And same with BuffKit, you can overlay that on your forecast soundings as well. So as we started to get building surface inversion or a lowering inversion, we started to lose the moisture profile in the dendritic growth zone. We still had enough moisture and enough cooled air here, even colder at the surface, to promote snow showers. But at this point, I think we were ending the event. We probably weren't seeing the dendrites like we were seeing earlier in the event, and thus kind of ending our snow event. So how do we generate our forecast using the top-down methodology? So it all translates to the graphical forecast editor, which is our GFE that we use. And so how do we produce a forecast like this? I do note, though, that this is not the real forecast. Michael took this from somewhere that's actually experiencing cold weather right now, and it's not here, thankfully, which I'm okay with. But so with the GFE, this is what we look at, and I'm sure a lot of you are familiar with this. This is a 2.5 kilometer resolution forecast that we input our parameters into. And so with this and with winter, we use this top-down methodology. And we start by using the National Blend of Models, or the NBM. You heard us mention this at last year's workshops and with information last year, and I think even prior to that. And what the National Blend of Models is, it's just basically everything but but the kitchen sink that gets put into this one national blend. So every model that you can think of here, I have on the slide a couple different examples that is thrown into this model output. So this is what we start with when we're initializing our grids. And so at that point, then we just go from the top down. We look at our max temperature aloft. We look at the probability for ice present, given any warm levels, potentially refreezing to sleet if we have a colder column beneath that. So it's essentially just taking that top-down approach in our grids. It looks a lot more complicated on here, but that's basically the general process. And at that point, then the grids will then take and derive a weather type from that. So even though there might not be the potential for precipitation, it'll still tell you if there was potential for precipitation, what that likely precipitation would be in a sense of snow, sleet, freezing rain, or rain. And at that point, then GFE is able to output the anticipated weather type, whether that be rain, snow, a rain-snow mix. And so that's the output that we eventually get at when we're producing these forecasts. And then, you know, all along the lines here, we QC the data, we tweak the data. This method isn't perfect by any means, but it is a great approach to how we at least initialize a first step in our forecast before we start to make sure that it makes sense and that it is it's realistic of what we can expect. So with that, I'm going to, make Fred a presenter so he can now speak. Fred, are you able to?
Yeah, I'm here. Hopefully, yeah, there you are. You all can see me. Cool, good deal. Yeah, thanks, Miranda. So we'll kind of switch gears here and talk about this winter storm severity index. This is something that's kind of the presentation, the PowerPoint file will have a lot more information about this and what I'm going to cover. It kind of gives you the kind of the background, but this is a project that's been evolving over a couple of years. And so this year will be the first full year that we'll be using this locally in terms of, you know, producing the grids and producing the graphics on our web pages. But essentially what it does is it kind of combines a bunch of parameters together. So we go to the next slide. You'll see a bunch of the parameters that are taken from our forecast that we make in GFE using the top-down method, and, you know, snow load in terms of, you know, if we have a lot of snow, like Superstorm Sandy was a great example of a snow load event where we had 4 feet of snow on roofs in the mountains, and, you know, we had some roof collapses. Snow amount, that's kind of what the main thing we'll be using locally, because, you know, we don't have a lot of big snow load events, but snow amounts using our forecast that we produce. Out 84 hours. Ice accumulation will be another thing that we'll be using as well in terms of our freezing rain forecasted amounts and the impacts from there. If we do get a big wind event behind maybe a nor'easter or a big low pressure system, blowing snow could be an issue. It incorporates that, you know, so that's snow and wind speed, you know, the snow content. Remember, it's got to be a low liquid to snow content. So the higher ratios, 20 to 1, 25 to 1, the ones we get from clippers and then the wind behind them are ones that we could have a blowing snow impact. And then flash freeze. So I put an image with flash freeze because that's something that kind of the public, I don't think understands as much. Again, this is, you know, specifically when we have like a rain event and temperatures really fall into the low to mid 20s. Secondary roads become very icy and you watch out for slick spots. So again, this is something else that it takes into account as well. And the winter storm severity index from the previous slide, the graphics, just showed the kind of all of them put together. So we go to the next slide. And we have some examples here. So this is from an event that happened on the left from January back last year. Again, you can see, you know, it quantifies it based on impact. So again, you know, low to extreme. And on the image on the left was the orange and some moderate impacts reaching across parts of western and central Ohio. And you can see based on the color code what a moderate impact is. The image on the right is really from the only snow event that we really had in the Pittsburgh region last year. But was interesting, if you recount this event, this is the one that produced about 5 inches of snow in Allegheny County. The snow started about 4 or 5 in the morning. The heaviest snow rates came in after about 6:30, and they ended about 8:30, 9 in the morning. So schools initially delayed, hoping the snow will be removed and be taken out. Well, the snow rates came in, got more intense, and then schools ended up canceling. People got late to work. And so, you know, if you look at this image on the right, you can see the orange kind of really focused around the Pittsburgh metropolitan region. One of the cool things about this is, you know, not only does it take into account, like, you know, different types of trees in different areas, but it also takes into account, you know, population and, you know, where areas that are more urban versus rural. So there's a lot. I would encourage you all to go through the presentation to kind of see kind of some of the stuff that it incorporates, because it's very slick in how it does this. And one of the things that I just found out this morning on a call with the Weather Prediction Center was that there's a national package delivering company that pretty much uses this winter storm severity index to make decisions whether to open or close distribution centers based on the level of impact. So again, so this is being used by a lot of large private sector industries, and so we're looking forward to see how it works this year across our region.